Hey, welcome back. Today is a new series. I have an interview coming up, so I'm going to treat this as a way of practicing. I won't tell you what company I'll be interviewing with in about 4 weeks, but I'm going to run you through some questions that may be related to the company I am interviewing with. So, just a way for me to practice and for you to see how maybe you can prepare for a company as well. So first up, I have done some of these before, but I'm going to go through, make this a whole series where I'm just going to go start at one, go all the way through. How many are there? Oh my goodness. How many pages? 62 pages. Oh my goodness. Okay. We'll see how far we can get through in the next 4 weeks. But yeah, I plan to do about probably an hour's worth today, but we'll see how many I can get through. So we're going to start out with question number 1. So our first question, it is the two-sum problem. You've seen me do this question before, and yeah, let's see what's going on over here. Why don't I have code? Here we go. All right, so it's a two-sum problem. We've done this one before, but I'm going to walk you through how I would talk about this. So we have the two-sum problem. So what we want to do is we need to be able to find numbers that are complements to each other to add up to a single target. So one way of doing this would be brute force, where I check each number against another one. So index 0 to 1, if I put them together is a target. Index 0 and 2 together is that target? No. Index 0 and 3, and so on. And then move on from index 1 plus 2, index 1 plus 3, index 1 plus 4. That is the brute force method. But if you've seen my previous episodes on hash maps, we did in fact cover this problem. So that is something that we will implement. The idea being that we have our hash map of the number. Specifically with this question, we're not producing the numbers, we're producing the indices of these numbers. So we would have the complement as our key, and the value would be the index of the number. So what we're going to do is we're going to start out by initiating a new map. I like using maps. You can use an object if you want, but I just like, it's in my head, it's more simple to use a map. They made a map object for a reason. So first up, I'll start off with let complement map equal new map. It will be an empty map, and then we know, according to this problem, exactly one solution. So we only need to find one solution and break out. So what we're going to do is do a for loop, because we're going to start out with each one, and we're going to loop through each number just one time. So instead of having an n squared situation where each number has to be compared to each number, we're just going to go through one time. So this would be O of n. That'd be our time complexity. And with our complement map, this would also be worst case scenario O of n space. Because it could be that the last number is the only one that has a complement, or the last two. So we're going to go ahead and jump in. So we'll do a for loop, and then here we don't want to do num of nums because, well, we need to keep track of our indices. So we'll be a classic let I equal 0, where I represents our index. I is less than nums dot length, and then we'll do I increments, because we'll move through just one time. So this is going to be one for loop. So this would be an O of n operation. So what we want to do is get our complement first. So we'll say const, and then we'll say complement equals, and what we want to do is say target minus, what are we going to minus? We're going to say nums at I. So this will get our complement. And what we want to do is first search for the complement. So if let's see, complement dot, remember we have to use this one here, has, and we type in what we want to do is search for our complement. If complement map has our complement that we are looking for, then what we want to do is we want to return, this means it's a match, we want to return an array, it looks like. So our array would be our complement map, and we want to use our get function because we want the value attached to this key and this complement, and we want to match it up with our current index, which would be I. So that's what would happen. Else, what we want to do is, if we do not break out, what we're going to do is say complement map, and we need to set a new key value pair. So what we're going to do is set, what are we setting? Our nums at I, and the value it is attached to will be the index. And let's see, assume each will have exactly one solution. So we're making the assumption that there will be an answer, and we don't need to have a return statement at the end because we are expecting this to work. Now, with this company that I'm interviewing with, we're not allowed to actually test the code. You have to do it yourself. So we can go ahead and test it ourselves. So we have a 2, 7, 11, 15, and the target is 9. We're expecting an output of 0 and 1. So that would be our first and our second elements in the array. So let's run through it. So we initialize the map, okay? Then we say our complement is target, which would be 9, minus nums at I, which would be 0. So 9 minus 2, our complement is 7. So then we see, does our complement map have the 7? It does not, it's empty. So we continue, and then we say complement map dot set, and then we say nums of I, which is our number, and then we attach the index to it. So our map now has a 2 key attached to a index value of 0. So 2, our key of 2 has a value of 0. Next, we're moving on to, we increment our I now equals 1. The complement is equal to target minus nums of 1, which would be our 7. So our complement would be 2. So if our complement map has 2, it does, because our 2 key is attached to a 1 or a 0 value. What we do is return the complement map dot get, which is the value attached to the 2 key, which would be 0, and our I. So our output would be 0 and 1. And that is what we are expecting. All right. Same thing over here. We have a 3, a 2, and a 4. And we have a target of 6. So again, we initialize our map. We'll do a for loop. So our first complement is, what is that? So 6 minus 3. So our complement would be 3. 3 does not exist in here. So we continue on down here and we set the value of nums of I, which is 3, to its index, which is 0. So we have a key value pair of 3 and 0. Next up, we move to I equals 1. So we have a constant complement equal to target, which would be our 6 minus our nums of 1, which would be a 2. So 6 minus 2 is 4. 4 does not exist, only a 3. So we move on and we set our 2 to have an index value of 1. Next up, we move to our second index, which would be our third element. So I equals 2. The complement equals our target 6 minus our nums of 2, which is 4. So 6 minus 4 is 2. That's our complement. Our complement map does have a 2. So what we do is return the value attached to the complement 2 key, and that is a 1, which would be this position here, and the current I, which would be 2. So that would also be a A1 and A2. So we're going to go ahead and run it just to test it. And we do pass all the cases, and then we'll submit. And over here, we'll see if we actually pass it. We do pass it. We are better than 79.54%. Our memory, not so good. Probably because I use a map. That's fine. C'est la vie. All right, let's move on to our second question. So add two numbers. So this is a blah, blah, blah. Our numbers are a list node. So we have 2, 4, 3, 5, 6, 4. We get 7, 0, 8. So basically our numbers are backwards. So this is 342. This is 465. And you add those together, you get 807. So we have our list node class already created here. Let's see, we have a var add two numbers equals function list 1, list 2, and our carry of 0. So because we have our carry here, this is implying to me that this will be, it's expecting a recursive answer. You probably don't need to do recursive, but we're going to go ahead and do it that way anyways. So you may assume the two numbers do not contain any leading 0 except the number 0 itself. Okay. Blah, 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 blah. All right. So what we want to do is, so we're going to create our node. So first up, what we're going to do is say const node. And our value, what is our value going to be? Let's not start there. So first we want to get our value. So we say const value, maybe, let's see, blah, blah, blah. We'll call it cursum. Cursum equals, and what we're going to do is say L1 question mark, because we don't know if it exists. Dot val. So L1 question mark dot val. So we don't know if L1 exists. It could be null. And if it is null, what we're going to do is substitute a value of 0 plus the L2, our list node 2. We also don't know if it exists, so we'll put a question mark there. Dot val or 0. And then what we also want to do is say plus carry. So the value of our carry will be our cursum, but with recursion, what we also want to do is have the case where we break out of it. So if there is no L1 and there is no L2 and carry triple equals 0, then what we want to do is return. But what are we returning? If there's no next one, we always want to return this value here, null. So we want to return null. So this will be our breakout case, or break case if, base case, I guess, if we want to break out of our recursive function. So we have our current sum, which would be all of this together. And so what we want to do is say const, let's see, cur node equals new list node, and let's see, our value, what is our value going to be? It will be this number, but if it's greater than 10, we don't want to set it. So we'll say our list node value is cur sum and divided by the remainder of 10. So if there's a remainder of 10, that will be the value of this node. So if these together is 12, the remainder of 10 would be 2, so this value would be 2. And then what we want to do is say const new carry equals, and what do we want to do first? We want to say, is our cur sum greater than or equal to 10? If so, we will say 1, else we'll say it is 0. And then next up we want to do is say that our cur node dot next, so the next node in our sum value, I guess, our sum list of nodes would be, so cur node.next would be equal to, and this is where our recursive call comes. We do add two numbers. So we say add two numbers, and what are we passing? We're passing list one. Again, we don't know if we have it. Dot next, or what? Maybe we call it null. Also, we're going to pass our list two, but we don't know if we have a list two. Dot next, or null, and our new carry. And then what we want to do is return cur node, which will return all the values following the cur node. All right, so let's go ahead and go through this really quick. Let's start out with these two here. So we have a 2 and a 5, and our current carries. So list node 1, we have a value of 2. So this exists, so we automatically go down here. Our cur sum, list node 1, it exists. Our value is 2. Okay, we have 2 plus list node 2. It does exist. We have a value of 5. So 2 plus 7, good. Our carry is 0. So our cur node of the value of our cur node will be a new list node with a value of 7 with a divided by 10 to see its remainder, or the remainder would be 7. So our cur node would have a value of 7, new carry. 7 is not greater than or equal to 10, so new carry would be 0. So our cur node dot next will equal to list 1 dot next, list 2 dot next, and our new carry, which is 0. So then our current node right now has a value of 7, which is what we're looking for. Next up, we have list 1, which would be our list node 1, which would be our new value of 4, our new value of 6 for list node 2, and our carry would still be 0. They both exist, so at least one of them exists, so we move down here. Our current sum is 4 plus 6 plus carry, so that would be 10. So our cur node is equal to new list node, and the remainder of this divided by 10, which would be 0. So our cur node would be 0. It is 0 here. And then our new carry, it is greater than or equal to 10, so our new carry is equal to 1. So this would be 0. So cur node dot next. So creating this new node here would be the list node 1. It does exist. So we move over and we jump up here. Again, we have a value of 3, a value of 4. Our carry is 1. So we have 3 plus 4 plus 1 is 8. So our cur sum is 8. Divided by 10, there's no remainder. So our cur node value, divided by 10, there's a remainder of 8. So our cur node would be have a value of 8. New carry, the cur sum is not greater than 10. It is 8, so it would be 0. So our cur node dot next would be list node 1 dot next, which would be null, list node 2 dot next, which would be null, and new carry of 0. So when we call it again, there's no list 1, there's no list 2, or list node 1, list node 2, and carry is equal to 0, so we would return null. So that would be, there'd be no next list node. So our output would be 7, 0, and 8, those 3 nodes in a row, which is pretty cool. So we're going to go ahead and might as well run it. Let's see, does it work? It does work. Awesome. Good. Good. All right, so we'll go ahead and submit our code. Let's see what we get over here. Does it pass all the tests? It does. All right, we are better than 77.82 percent of users. We beat 14.94% of users. There's probably some people who just, kept it inside one of these list nodes that didn't create any new values, I guess, or a new list node. But we could probably go back and optimize it to do it that way. But I don't like changing the arrays or the list nodes that we were given. I like creating my own because you never know when you might need to reuse it. We're gonna move on. Maybe try and do one more. I think I could beat it in under 30 minutes. So here we go. Length of longest substring. So given a string S, find the length of the longest substring without repeating characters. So if A, B, C, B, B, output would be 3 because A, B, C does not repeat. So let's see. Looks like it's going to be a classic use of a set. So a brute force would be to check each one of these. So starting over until you reach a repeating character. That'd be n squared, but we can do it in O of n by using a set. So the way I want to do it is, idea would be that we have a set. We have a two-pointer system where we move the right pointer forward every time we have a new character, and then we move the left pointer forward every time we run into a repeat, and we add and delete items from the set depending on whether or not we have seen it or not. So let's go ahead and create that. So let scene, this will be our scene set, equal a new set, will be empty. And let's see, what we want to do is we don't need to keep track of our index, but we do want to keep, we have to have our pointers. So let's say let left pointer equal 0, let right pointer equal 0. So this is a classic two-pointer problem. I'll dive deeper into these in another video. So what we're going to do, we're going to be using a while loop. So while, let's see, our right is less than, what are we saying? Less than our s.length. So once we break out with our right, that is when we want to end it. So while right is less than s.length, what we want to do is say if scene.has, and let's see, if scene.has, what are we saying? If scene.has s at right, what we want to do is say scene.delete, and what are we deleting? S.left, and then we say left plus plus. We increment our left. Else, our other choice would be if scene does not have s.right, what we want to do is add it and then increment, and what we also want to do is keep track of our current max. So let cur max will start at 0 here. So else, what we say is scene dot add, and we'll say s dot at right. So we add it, and then we increment our right plus plus. And because it is 0 index, we want to increment it first before we say cur max equals math.max, and we're going to be comparing our cur max to right minus left. And then at the end of this all, we say return our cur max. We'll do a double R, double R, double R, double R, just to keep it consistent with everything. So we have our scene, We have our left pointer, our right pointer. So these will represent our indexes that we are comparing. And our cur max, which is the length of the current substring with no repeating characters. So while right is less than the length of s, if scene has the s of right, so basically the idea would be, we'll go through this together. We have a, scene does not have it, so we go down here. We add a to here. We increment our right pointer, so now it would be 1, and we say cur max equals math.max of cur max, which would be 0, and right minus left, which is 1 minus 0, which would be 1, so our cur max would be updated to 1. Then we have b. So the left pointer is the pointer of the start of our substring. The right pointer is the end of our substring. So we have A and B. So our B on our right would be, it has not been seen. So we add B to our scene list. We increment B plus plus. Our pointer is now at here, 2. And we say cur max is equal to math.max of cur max, which is 1. And right minus left, which is 2 minus 0. So that'd be 2. So we update our cur max to 2. Next up, we have pointers at 0, 1, and from 0 to 2. So we say, does scene have s at right? C, no, is not in scene. So we move down here, we add C to our list, we increment it up to here. So our pointer, our right is now at 3. And our cur max is equal to math of max, the cur max of 2, and right minus left, which is 3 minus 0, which would be 3. Our cur max is now 3. Next up, we hit our first A. Okay, A. Let's see. We have seen A. So what we do is delete our A from here, and then we move up to here. So we delete A, and we increment left up. And we start over. Next up, our right pointer is still at 3. Our left is at 1. And we say, does scene have A? Not anymore, we deleted it. So we come down here, we add A to it. We increment our right to 4. And then we say math.max, cur max, which is 3. And right minus left, which is 4 minus 1, which would be 3. They're the same, so we do not change our cur max. We keep it the same. And then we hit another B. Again, we go through this. We delete our B. We start over. We have C, A, B. We add B. B is no longer seen anymore because we deleted it. But it is the same. So our max of 5 minus 2 is 3. Is the same as our current max, which would be 3. So we keep 3 here. Then we move on, we have C, A, B, C. We have seen C before, so we delete our C from our scene and increment our left pointer. And we have A, B, C. Again, we add it, but it is the same length as our previous cur max. And yeah, so this should work. Let's go ahead and run it, and let's see if it does in fact work. Good. We have case 1, case 2, case 3. They all work. And of course, with the larger test suite, let's see if it actually does work. Ba-bam. Here we go. All right, awesome. So our runtime is 80% better than everyone else. Our memory, 55. I'm fine with that. That's nice. I'm proud of that. It's probably my best memory so far. So yeah. I'm going to go ahead and cut it off there. Those were 30 minutes worth of questions that we ran through. I hope you were able to follow along. I hope my explanations were good. And I want to thank you so much for letting me practice on you while also trying to inform you as I prepare for this interview. Anyways, thank you so much. If you have any questions, post them below. I'll try and get back to you guys. And yeah, happy coding.